So we've been taking a look recently at the relationship between the x and the y, the input and the output. Right now we're going to expand on that with the domain and range. Let's start with the domain. Now the domain just means all the x values that are included in a function, all the x values. And notice two things. Your domain cannot have a 0 in the denominator, and it cannot have a negative square root. If you stick to those two things, you're always going to be able to rule out which x values are not included. So let's take a look at this first function. Here we have f of x equals 1 over x. Well, I don't notice any square roots, but I do notice a variable in the denominator, and I know I cannot have a 0 in the denominator. So I know that this x cannot equal 0, because if it did equal 0, then there would be a 0 in the denominator of this fraction. Now how we write our domain, we're going to use set builder notation here. So basically for our domain, we go from negative infinity, all numbers all the way to negative infinity, all the way to 0, and we're going to put a parentheses here. This parentheses, remember, means this 0 is not included, and we're going to combine that with 0 all the way to positive infinity. So because these zeros don't have brackets, that value is not included. Let's take a look at this next one. F of x equals square root of x. Now this time we do not have a denominator, but we do have a square root. So I know whatever's inside my square root, in this case x, has to be greater than or equal to 0. Because if I had anything less than 0, it would make this negative, which we can't have a negative square root. So how we're going to write this in set builder, this time we include 0. So I'm going to go ahead and put a bracket with 0. And now I don't have any negative infinity like this one, because remember, this has to be bigger than 0. And we're going to go from 0 all the way to positive infinity. We include all positive numbers all the way, keep going and going and going. And we always put a parentheses around the infinite sign. Let's take a look at this example. Here we have g of x equals x plus 1 all over x squared minus 3x minus 40. Now I don't see a square root, but I do see a variable in the denominator, and I know that's not going to be able to be equal to 0. So what I'm going to do here is I'm going to set up x squared minus 3x minus 40 equals 0, and I'm going to do that because I'm going to find out which values of x will make this x squared minus 3x minus 40 equal to 0. So taking a look at this, I know I'm going to need to factor. This will give me x minus 8 and x plus 5 is equal to 0. That's going to give me values of x equals 8 and negative 5. Now remember, these are the values that x cannot equal. X cannot equal these values because it will make the denominator 0. So if I put this in set builder notation, I know I'm going to get my domain values all the way from negative infinity to negative 5. Remember, negative 5 is not included because it will make this 0. So I put a parentheses around that. I'm going to union that from negative 5 all the way to 8. And again, I'm putting a parentheses because 8 is also going to make this 0, which I do not want. And then I'm going to union that with 8 all the way to positive infinity. So if I read this, I know my domain, my x values, can go from negative infinity to negative 5, not included, negative 5 to 8, not included, and then 8 all the way to infinity. Alright, continuing with our domain, here we have f of a equals square root of 2a minus 1 all over 3. This time I do not have a variable in the denominator, but I do have a square root, and I know that square root value is going to have to be positive. So what I'm going to do here is I'm going to set up exactly what's in the square root, which is 2a minus 1, and I know that has to be positive or greater than or equal to 0. Now if I solve from there, I just add 1 over, I get 2a is greater than or equal to 1, and then I'm going to get a is greater than or equal to 1/2. So these are my possible values x values for my domain given this function, because it has a square root, has to be bigger than 0. Putting this in set builder, I'm including 1/2 because we have this greater than or equal to sign. So I put a bracket with my 1/2, and that's going to go all the way to positive infinity. And there's my domain. Now let's take a look at finding the domain and the range using a graph. Remember, the domain is all the possible x values, and the range is going to be all the possible y values. For example, here we have a parabola, and the domain here, no matter what x value we choose, if we go high enough, it will have a value for all x values. So our domain, I'll put a D for domain, is going to be negative infinity to positive infinity. And the range now, I'll put an R for range. Here, notice if we start in the negatives, we do not have any y values. Our first y value is actually at 0, and then going in the positive direction from there. So our range is going to include 0 all the way to positive infinity. Again, because only positive values in 0 have a y value on this graph. Looking at this graph here, we've got a straight line, and we've got a y value, a value for every x value. So our domain is going to be negative infinity to positive infinity. And it looks like we also have a value for every y value. So our range is also going to be negative infinity to positive infinity. Okay, looking at this graph over here, this time we don't have a value for every x value. See, for these x values in the negative area, there is no value. So for our domain, we're going to be starting at 0, because 0 right here is our first x value included, and then we continue on all the way to positive infinity. So here, 0 included all the way to positive infinity. And our range for this one, up here, we don't have any values for these y values. In fact, until we get all the way down to -1. So our range is going to be at -1, going down to -2, -3, all the way to negative infinity. So for our range, we're going to be going all the way from negative infinity to -1 included. Let's take a look at two more really quick ones. These look a little different, but are very important to point out. So here we have a graph with arrows coming up in this direction and then arrows going down in this direction. So taking a look at the domain for this one, all x values. Now all these negative infinity x values are included until we get to 0. So for our domain, we're going to be going from negative infinity to 0, not included. But then right once we get past 0, we start right back up again all the way to positive infinity. So this is going to be union with 0 not included all the way to positive infinity. Our range for this one is actually going to be very similar. Our y values, we have values all the way until we get to 0, then we skip 0, and then all the way to negative infinity. So our range is going to actually look just like our domain, negative infinity to 0, union 0 to infinity. Looking at this graph on the right here, we've got a circle. Our domain is going to include all values from, let's take a look here, starting at -3 all the way to +3, we have values for each x value. So our domain is going to go included from -3 to +3. And our range is going to be very similar, except looking at the y values. Here we have the first y value at -3 all the way up to +3. So this is actually going to look identical to our domain once again from -3 to +3.